This problem is about a baker who is going to sell some bread at a farmer's market, and he makes two different kinds of loaves. He makes wheat bread and he makes cheese bread, and each one has certain things about it. The wheat bread takes an hour and a half to bake. The labor involved is a third of an hour, and the profit from each loaf is $1.20. The cheese bread takes an hour to bake. The labor is a half hour, and the profit is $1. So we know this information about the breads that he's making, and we also know that there are limitations on the labor and the oven space and baking time and all that stuff. And we're trying to figure out how much he should make so that he can maximize his profit when he goes to the farmer's market. So the number of loaves of each type of bread, X will be the number of wheat loaves, and Y will be the number of cheese loaves that he makes. So we know that the number of wheat bread loaves he makes has to be positive. So X has to be greater than or equal to 0, and the number of cheese bread loaves he makes also must be positive. So that will be greater than or equal to 0. We are also told that the oven space restricts him from making more than 120 loaves. So at the max, he can only make 120 loaves. So that means X plus Y must be less than or equal to 120. We also know that the amount of oven time for baking is no more than 165 hours. So for each wheat loaf, the time in the oven is an hour and a half, according to the table. And for each cheese loaf, hour in the oven is what we're told. So the number of oven hours that we'll be using is going to be X times 1.5 plus Y times 1, and that has to be less than or equal to 165 hours. Okay, so now that we have that equation, I'm going to go ahead and solve it for Y, move everything to the right side and leave the Y on the left side. So that's Y less than or equal to negative 1.5X plus 165. So that is the equation about oven time. All right, then we are going to have another situation. We have the amount of available labor is at most 55 hours. So people to work to make the bread, at most he can get 55 hours of time. So that says that for the wheat bread, it's a third of an hour per loaf. And for the cheese bread, it's a half hour per loaf. So 1/3 times the number of wheat loaves, which is X, plus 1/2 times Y, the number of cheese loaves, has to be less than or equal to 55 hours. And we can solve that for Y by moving the 1/3 X to the right side and then multiplying everything by 2. So Y is less than or equal to negative 2/3 X plus 110. Okay, so these are all the equations about time, labor, oven time, all that stuff. What we want is to maximize the profit. And the profit is just how much he makes on each loaf. So $1.20 times the number of wheat loaves, which is X, plus $1 times the number of cheese loaves, which is Y, will give us the profit, Z. And we're trying to make that Z as big as possible. If we graph all of these inequalities and shade as we should, what we're going to get is called the feasible region. And that's a region of points in the plane, X, Y, that will all work in all of these equations we have. Some of them are better than others, though, as far as maximizing profit. So I'm going to put all these equations on here one at a time. X greater than or equal to 0, Y greater than or equal to 0, the number of loaves of each kind has to be positive. And that just means that we're only going to be working in the first quadrant above the x-axis and to the right of the y-axis where everything is positive. All right, then we had the function or the line, the inequality about they're only going to make as many as 120 loaves, no more than 120 loaves. So X plus Y less than or equal to 120. And if we solve that for Y, we're going to have Y is less than or equal to negative X plus 120. So we're going to go ahead and graph that line, which has its y-intercept at 120 and has a slope of -1. So it's going to look like this. And we're going to already go ahead and decide whether we're going to shade above the line or below the line. If we plug in 0, 0 into this function, we get 0 is less than or equal to 120, which is true. And so we will shade below the line. All right. The next equation we had was the one about baking time. It said 1.5 hours per wheat loaf and 1 hour per cheese loaf. So 1.5 times x plus 1y has to be less than or equal to 165 hours in the oven total. And so that line, if we solve for y, we're going to have negative 1.5x plus 165. So our y-intercept is going to be 165 and our slope is negative 1.5. So here is what that line is going to look like. And to know where we would shade, we can plug in the point 0, 0 into that inequality, and we'll get 0 is less than or equal to 165, which is true. So 0, 0 is below the blue line, which means that's the side we would shade. The next inequality is about the number of hours of labor that he can get. So this takes a third of an hour of labor for each wheat loaf and a half hour of labor for each cheese loaf. So 1/3 x plus 1/2 y has to be less than or equal to 55 total hours of labor. So these are all the conditions that are on this, and we're going to go ahead and do the green line. So we'll get y by itself. 1/2 y is less than or equal to negative 1/3 x plus 55, multiply by 2, and you get y is less than or equal to negative 2/3 x plus 110. That green line has a y-intercept of 110, and then it has a slope of negative 2/3, and so it looks like this. So we are going to figure out what side of the green line to shade, and if we put in 0, 0 to that inequality, we get 0 is less than or equal to 110, which is true, so we will shade below the green line. So the region that is our feasible region is the region that is below all three lines. And so that looks like this. And then we're going to look at all the vertices of that shape. So they're the only ones we need to check to maximize the profit. We just have to figure out which one of them makes it maximum. So the ones that are on the axes are easy because we can see what they are. So those 3 stars, the top one is 0, 110. That's that point. Then we have 0, 0, and we have 110, 0. So those 3 points are on the shape, and they're possibilities for our coordinate pair that will maximize profit. 2 other vertices on this shape. One of them is right there where the green and red lines cross. So we have to find out where those 2 lines cross. So we've got y less than or equal to negative x plus 120, and we have y less than or equal to negative 2/3 x plus 110. So we're going to solve that system of equations, or they're not really equations, they're inequalities, but we're going to set them equal to each other. So we've got negative x plus 120 is equal to negative 2/3 x plus 110. Solve for x by adding 2/3 x on both sides. So we would have 1/3 x equals negative 10. Multiply both sides by 3, negative 3, and x equals 30. So if x is 30, we can plug that back into either one of those inequalities. And when we plug it back in, we will get y equals 90. All right, so that point where the green and red lines cross is the point 30, 90. So that would be when you bake 30 loaves of wheat bread and 90 loaves of cheese bread. The other point is where the blue and red lines cross. So that's right there. And to solve for that point, we're going to have to solve the system of equations that has the blue line and the red line. So we've got y equals negative x plus 120. And then we have the blue line, which is y less than or equal to negative 1.5x plus 165. Now we can use substitution to solve that. So negative x plus 120 is equal to negative 1.5x plus 165. We can add 1.5x on both sides, and we will get 0.5x equals 45. So x will be 90. And when we plug that back into either the red or the blue equation, we are going to get y equals 30. So the point where the blue and red lines cross is the point 90, 30, which is when you bake 90 wheat loaves and 30 cheese loaves. So we've got 1, 2, 3, 4, 5 points, the vertices of the shape, and we will check each one in the profit equation. So we want to maximize profit, and that is $1.20 times X for the wheat bread, $1 times Y for the cheese bread. If you add all that up, that will be your profit you will make. We're going to check each one of these points and see which one gives us the highest value for Z. So the biggest, the profit is maximized, $138, when you make 90 wheat loaves and 30 cheese loaves. So that's what he should do if he wants to make the most profit.